Greetings everyone, my name is Ananthapadmanabhan and I am going to be presenting a presentation on static electricity. So, first and foremost, I apologize for the lack of formality in this presentation. I figured out that too much formality would make this presentation a bit intense, and I wouldn't want this presentation to be intense, so I guess I will be sticking on to a semi-formal pattern or a model of conducting this presentation. And I will be using the help of a script which I have written beforehand. So before moving on to the main content of this presentation, I would like to start with a small introduction, a brief explanation of the fundamentals regarding static electricity. So I'll be moving on to the script right now. According to contemporary scientific knowledge, the atom is the smallest unit of matter. This minute unit embodies subatomic particles such as neutrons, protons, and electrons. The imbalance of any of these subatomic particles can result in drastic changes. We will paraphrase and demonstrate these changes taking place when there is an imbalance of electric charges. So static electricity is essentially the imbalance of electrons on or between surfaces. Unlike electric current, static electricity is more or less stationary unless and until there is an external trigger or an agent of conduction. We will mainly look into the triboelectric aspects of static electricity today. Tribo is a Greek word that translates to rubbing. Triboelectricity is basically the charge an object acquires after being in physical contact with another material of different polarity. Fundamentally, polarity is the state of being positively charged or negatively charged. So, now I'll be moving on to the demonstration part of it. We will understand this concept using a demonstration. For that purpose, I will be using a device known as an electroscope. An electroscope is a device used to detect static electricity. So this is how usually an electroscope would look like. An electroscope is comprised of an airtight chamber, a copper wire which is coiled on top and has a hook-like appearance in the bottom part, and there are two strips of aluminium foil which are hung on the hook, I guess. And then what happens here basically is that when a charged object is brought near the coil, the electrons from the charged object actually gets transferred to this coil here, and then it gets conducted downwards to the aluminium foil. So what will happen is that both the aluminium foil get negatively charged, and when both of them get negatively charged, they have similar polarity, and so they will repel. So for that purpose, I'm gonna use this polycarbonate rod. You can see this is a polycarbonate rod. Actually, commercially, polycarbonate rod is available. It's bland. Actually, I turned out to be lucky. I got a designer one with bubbles inside. So that's the thing. And I will be using this woolen fiber. So the reason why I'm using woolen fabric is that it is mostly negative in charge. It's usually negative, and because it has abundance of loose electrons. So basically, when the rod is being stroked with the fabric, some of the electrons tend to stick to the surface of the rod. These electrons have nowhere to go and remain there till it is brought close to a conductor. An electroscope is a device that is used to measure static electricity. So basically, the copper wire will conduct the electrons from this rod, and we can see that right now. Here we can see the aluminium foil. Both are leaning away from each other, which means they are repelling each other. This is a classic example of static electricity. In our first experiment, we can see a matchstick hanging by a string inside a container. You can see that when I bring the negatively charged rod closer to the match, it will start attracting it as the match is now positive in charge as compared to that of the rod. Here, electrons move from the rod to the match, causing the match to be attracted to the rod. Sometimes when the rod is really charged up, the surface of the container will get negatively charged, causing the match to stick to the surface of the container until their charges get neutralized. This is black pepper powder, and here the black pepper is positively charged as compared to the negatively charged rod. So the pepper floats up and sticks to the rod as it is light, similar to what we saw in the previous experiment. Some people who have seen this presentation in the past have commented on its lack of innovation. So the upcoming session is a compilation of all the innovative ideas and related things I've come across during the making of this session. First of all, people can electrically shock themselves under certain circumstances. This usually happens in winter seasons when people get up from bed and touch their doorknobs wearing socks or while standing on a carpeted floor. I thought about this scenario and I've come across all these factors that could alter the buildup of static electricity in our bodies. I came to realize that humidity plays, is a major factor, a major adverse factor to the accumulation of electrons in our body. And the winter season is apt for this kind of specific phenomenon as humidity is extremely low. Insulators like the bed, the carpet, the socks, the rubber sandals would block the body's contact with the floor, thereby helping in the accumulation of electrons. And the bed sheets made of thick fibers would, probably because of winter, would contribute to the electrons that the body has gained. The lack of moisture on the body surface will also play a crucial role here. I've had friends tell me how they have come across various forms of static electricity in their lives. Most of them had something to do with their hair floating around, and the reason for that is that when the hair is charged negatively, all of them will repel each other due to the similar polarity. Because when hair is charged negatively, each hair will have the same polarity and they will repel each other. Similar poles repel, right? And there is also historical relevance to static electricity. And I will explain how. The first recorded observation of electricity was by the Greek scientist Thales of Miletus, who found out that by rubbing two pieces of amber, he could pick up pieces of dust and leaves, particles of dust and leaves, and which is a classic example of static electricity. And this happened in the 600 BC. So it's pretty important. Another idea I've come across was another form of an electrostatic precipitator that could work by consuming the electrical energy of lightning and producing large amounts of ozone, which could be vented and stored, then later released at extremely high altitudes to prevent any adverse effects. At the same time, this would clean the environment, and ideally this machine should be located on a ship for easy relocation considering climatic factors. And also, if the lightning were to provide too much power, then the remaining electricity could be safely discharged into the open ocean. But this idea is set well into the future, and we don't yet have the technology to utilize lightning as an energy source. Nevertheless, I will hope for research on static electricity to progress, resulting in the formation of a decontaminated world.